Welcome to the Windshield Chronicles, a mental sequence of operation. This episode sponsored by Sunrise Refrigeration. Learn more about Sunrise Refrigeration at sunriseref.com. Dennis Soukup, thank you for joining us once again. Let's dive a little into building and designing a box.
Clift, walk-in box is one of my favorite things. Something I love to do every day. Even my guys are amazed. I just went out and finished a big 42-foot long glass door box for a new liquor company here in Las Vegas. And I love sizing and designing walk-in boxes. So I think one of the most important steps is, first off, you got to meet the customer. You got to know
Understand your
audience. Know the customer. What is he doing? What's his business? How is he going to use this box? Because once I start the layout, I want to see how he's going to load it. So I know which way to swing the doors. Do my hinges go on the left? Do my hinges go on the right? You don't want to be banging into the door when you're coming with a hand cart full of food. You want to have a natural flow. So that begins part of the layout when I draw it on paper before I go to the manufacturer. But above and beyond that, one, now I need to know what size box. What can he fit? When he says to me, I want an 8x12 box, okay. How high is that box? 8 by 12 by 8 feet high. Now, typically, I will go to the Heatcraft engineering manuals. I have found that to be one of the best tools, one of the most accurate. I have done walk-in boxes by letting other people tell me what I needed. And I'm sorry, they lived in San Diego, and the weather in Las Vegas is not San Diego.
Exactly.
So 3 months out of the year, that box would not run. And I have to be performing as well on July 4th at 110 degrees as I do on New Year's Day.
Sure.
So you have to learn to do your own calculations. So when you use the Heatcraft manual, there's an average and there's a heavy usage. Well, yes. I always stick with heavy usage.
You're heavy. You're high.
Now I take, and this design work on this is just kind of a generic for restaurant operations. Yeah. We have the expectation that there's a certain amount of product that comes in refrigerated already.
Yep.
It's not coming from a field, but it's coming from a refrigerated
has reduced temperature.
And you're going to continue that. And it could be multiple type things. It's got lettuce, tomatoes, chicken, maybe beer kegs, whatever. So you go to the engineering manual. I select the BTUs for heavy usage for that size box. That's my foundation. Now I'm looking for extra things. Is there forklift entry? Is there glass doors? For an example, any glass doors like you see in a convenience store merchandiser, if it's a 35-degree box, those glass doors are going to cost you 1,360 BTUs per
door.
It's per door, you got to add them up, because that's part of the total BTU calculation that I'm headed for.
Your refrigeration.
Okay. If it's a freezer, minus 10-degree glass door, 1,730 BTUs per door.
Wow.
You're adding that up, and now you're coming up with your grand total. And let's say I'm at a grand total of 40,000 BTUs with everything factored in. My lights, my people, my product, my glass doors. I have 40,000 BTUs that I need. I'm going to then step off and look for a compressor. Not for a compressor that can deliver 40,000 BTUs at 35 degrees.
Right, not at box temperature.
Right, that's box temperature. It has to give me 40,000 BTUs at 25 degrees because I have a 10-degree TD. A 10-degree TD on that coil. I need 25 degrees saturated suction temperature. That step causes most people to miss the mark, because when they do that and they miss that 10 degrees, they can't get that box below 40 degrees or 45.
Exactly.
That's the first mistake that was made. Now, I'm going to have to continue to interview the customer and find out, where does he want that compressor? Is it going inside the building on top of the box?
Conditioned? Is it in the sun?
Right.
Facing
when he
north,
says to me,
south?
well, no, I need it to be on the roof of the building. Well, the other important factor you need to know is I need that 40,000 BTUs no matter what the temperature is outside. Right. And I know now that when I go outside, the AHRI manuals are going to dictate that those BTU calculations are based on 95 degrees. So first off, the 3 months in Las Vegas that I'm at 110, I am well beyond the 95.
Right.
The deregulation factor for that is 6% for every 10 degrees beyond 95.
Above 95.
So now my 40,000 has been dropped by 12%. This could cause me
20
to
degrees.
select the next size bigger compressor.
Okay.
Because I still need the 40,000 downstairs is
For
not
your
changing.
box. Exactly.
The box BTU load is given. That is not changing. That's based on size, product, and other heat load factors, lights and doors. That is not going to change. The weather outside may, but I still need to deliver that 40,000 BTU.
Cooling capacity is still going to maintain.
The next thing you want to make sure of is when you have calculated out to your worst case scenario, let's say it's that 110-degree day is my worst case. I can't ever let my compressor output become smaller than the evaporator. In other words, if I let that compressor on 110-degree days slip to 38,000 BTUs, my evaporator is based at 40,000. I have just starved my evaporator.
By reducing the capacity of my outdoor unit.
The two things that technician is always looking for in setting superheat is he flooding or is he starving the evaporator, and he has to adjust expansion valves accordingly. When you have starvation built in, you can't fix it. You are starving. So the worst months of the year, your customer is going to be complaining, my box will not keep temperature.
That technician's up there checking superheat, and all he's going to do is overcharge.
Correct. He's going to try to compensate for something like that he cannot do. So now you have a balanced system. You have a compressor that's going to do it year round. You have an evaporators that are going to do it year round. You have the expectation that I don't care how he loads that box, I'm going to guarantee you, and that's what I do here. I guarantee you 35 degrees, 365 days a year. If I can, in most cases, and this becomes a price factor, I put in what I call poor man's redundancy. Now, poor man redundancy might be, let's say I need a 5 horsepower compressor with an evaporator. If I can break that box and divide it with an imaginary line, and I can put 2.5 horsepower units and 2 evaporators inside that box, that's poor man redundancy. Whereas one unit fails, the panic is not there. The second unit will keep my product refrigerated, and it won't keep me at 35, but it won't keep me at 65 either.
$20,000 worth of beer at 65 is not the same as 40
If you have a big freezer full of gelato and ice creams, and it goes down and you don't have some sort of redundancy, the only thing you can get is a mop and a bucket.
Absolutely.
Okay. Now, putting the box together, putting boxes together is not real complicated. I love it because it's like a puzzle. You get it from the manufacturer, you get a nice blueprint. You've already designed it, or I've designed it, so I kind of know where it's going to go and its shape and size. And you begin to look at which corner do I want to begin building so I don't make a trap. And then the key parts are getting your panels lined up, put into place, and they're usually locked together with a cam lock. But one of the most steps that I see missed, and I get a lot of calls from owners to say, what can you do to fix this? This is happening to me, is the step is what we call putting butyl to the warm side of the box. So you think of the box, it's 4 inches thick of foam with a cam together lock. So the outside panel, the outside edge of the panel is the warm side. Where you're standing in the box is the cold side. So you draw a line of butyl caulking from top to bottom on that panel before you squeeze it together and lock it. And that butyl will squeeze in there and fill in all the gaps where air might go. Now, if air can get in past the gasketing, it's going to look like under a microscope, like a Christmas tree shape, a dart, if you will, as it freezes. And it will freeze and start to separate that panel. The more it separates it, the more air that gets in. And it starts to compound itself to where it actually will destroy a box. And I've seen owners, I'll thaw it out, and they'll put silicone over it. It's not going to fix it. The air is still going to get in there. And that's the step that I most often see. They think you can just lock it together and the gaskets will take care of it. There's a fine line in the instruction manual that says apply butyl to the warm side. If you have a floor, you have to think about it. The warm side is the part that's touching the concrete, not the part you're standing on. If it's the ceiling, it's the warm side is the top of the box, not the part you're looking at when you're in it. And it's tedious because you got to have one guy I have on my crew. He's got the gun and the tubes. And as the panels, we stand them in place. We step back a second. He draws a bead of caulking, and then we lock it together and squeeze it together, so you now know no air can penetrate from the warm side and get in to the box. If you tried to do it on the cold side, that 4 inches, that air is going to come in into that 4-inch space and be right up against the internal side of the box.
And possibly introduce moisture into the foam area in between the panels. I've seen that here.
And it does. Over a period of time, it separates, it destroys, and it ruins the panels.
Absolutely.
So key things there, BTU sizing. Make sure you know the customer, know the BTU loads. Don't leave anything out. Calculate for lights, forklifts, people working inside boxes. There's a lot of manufacturing places that are packaging and doing things. All of those are heat loads. Heatcraft Engineering Manual will give you factors on all of those. You're getting all your BTUs added up right. Account for your losses if you're going to be in high ambient locations with that compressor. Think about poor man's redundancy. It kind of makes you the savior when you're talking to your customer, because you're thinking about their best interest when you're building the box. And calculate those BTUs so that you are not starving your evaporator on the hottest months. And sometimes you have to protect yourself on the coldest months. I still do that here in Las Vegas. I like using Headmaster mixing valves, so when the ambience drop below 60, that's the tough part. When air conditioners are shutting off, walk-in boxes still have to run.
Absolutely.
So we have to keep that head pressure up. So you're thinking about low ambient as well as I'm thinking about high ambient. High ambient based on my BTUs that I need, low ambient, ensuring that I'm pushing that refrigerant down that liquid line with enough pressure on a cold winter night. When you do that, you can guarantee that temperature 365 days a year.
What about metering device selection on our boxes?
Well, metering device selections are based again on BTU, based again on the evaporator. Just because you have like the air conditioner, you have a 5 horsepower compressor unit on the roof does not dictate that you have a 5-ton expansion valve in the coil. It's going to be based on the BTUs of that coil. I got to tell you today, things are there's so many new controls. We use a lot of this key-to-therm thermostats that have built-in defrost capabilities for medium temp boxes. Those are fantastic to prevent ice buildups. And quite frankly, I'm a fan. If I can get an electronic expansion valve in there, I'm an absolute fan, because the electronic expansion valve, number one, it's going to have 256 plus steps in it. It's going to do a lot of smart thinking for me in knowing where's that superheat at, where am I operating the best, and how do I get there the fastest? So that means, can I open up and then adjust down so that I can get right to that right amount of superheat? And the second thing is when it does, the key to therm tells it to cycle off. In today's code, it's going to pump down, saving me from having to have a solenoid valve, and then allow my fans to switch to a low speed, saving energy, meeting the 2020 walk-in box code. So electronic expansion valves, my favorite. You can't go wrong there. And when you communicate that with some smart technology, 2-speed fans, key to therm thermostat, programmable defrost for even medium temp type units, never getting that complaint of an iced up coil, absolutely the way to go. Expansion valves, either way, BTUs based on a coil, not horsepower based on a compressor.
Awesome. Dennis Soukup, thank you so much for your time. Once again, we sure appreciate you being here with us.
Awesome. Glad to be here, Clifton.